Gold has captivated humanity for millennia, and it is a unique element. It possesses a brilliant, warm luster that does not tarnish or corrode. For thousands of years, civilizations have used this precious metal for currency, for adornment, and as a symbol of power and eternity. Its story is one of geology, engineering, chemistry, and human effort. Yet, the gleaming bar of gold we might see in a vault or a museum does not begin its existence in such a perfect form. Its journey is long and arduous, starting as microscopic flecks trapped within immense tonnages of ordinary rock, hidden deep within the Earth's crust. This is the story of that transformation. The process is a testament to human ingenuity. It is a journey that takes us from the vast, open landscapes of exploration to the confined, dark tunnels deep underground. We will witness the immense power of machinery designed to move mountains and the delicate precision of chemistry used to isolate the smallest particles of value. The path from rock to riches is a complex one, involving geologists, miners, engineers, and metallurgists, all working in a highly coordinated effort. Each step is carefully planned and executed, transforming a raw, unyielding material into one of the most sought-after substances on the planet. This essay will trace the complete life cycle of gold production in a clear, step-by-step manner. We will begin with the search for gold deposits, then descend into the mines themselves, both on the surface and below it. We will follow the rock, known as ore, as it is blasted, hauled, crushed, and ground into a fine powder. From there, chemistry coaxes the gold from its rocky prison, and finally, intense heat turns it into liquid, ready to be poured into the iconic bar form. The journey of gold begins not with a shovel, but with an idea. It starts with geology. Gold is formed over millions of years through intense heat and pressure deep within the earth. Molten magma carries trace gold upward. As magma cools, water and other minerals are forced into cracks, depositing gold in veins. Over eons, erosion washes heavy gold into rivers and streams, forming placer deposits. The first step is finding a concentration large enough to mine. Prospecting uses maps, satellite imagery, and identifying rock formations and faults. Geophysical surveys detect subtle magnetic and gravitational anomalies that can indicate structures hosting gold. Once an area is promising, work moves to the ground, mapping, rock and soil sampling, and small test pits. Samples are sent to a lab for geochemical analysis, testing for tiny traces of gold, silver, arsenic, and copper.
We're looking for a ghost. A few parts per billion in soil can point to a massive deposit hundreds of meters down.
If samples look good, drilling begins. Large rigs extract long cores from deep within the earth. Geologists log every meter, rock type, structures, visible and microscopic veins of gold. It is painstaking work. Dozens of drill holes define size, shape, and grade. Only after extensive investigation can a company decide to build a mine. Each decision balances geological confidence, engineering feasibility, and safety. When a near-surface deposit is found, we open the landscape to reveal the ore. Next, the world of open-pit mining. When a large gold deposit is found near the surface, the most common method is open-pit mining. A massive, terraced hole accesses the ore body, several kilometers wide and hundreds of meters deep. Surface vegetation and topsoil are cleared and stored for later reclamation. Precisely calculated explosive charges fracture the hard rock in controlled blasts. Giant excavators load broken rock into haul trucks, some of the largest machines on Earth. They carry hundreds of tons per load in a constant cycle.
You're always focused on the road and the load. Safety is everything.
Ore goes to the processing plant. Waste rock to designated storage. Waste to ore ratios can be high. A mine operates like a non-stop city. GPS and software ensure the right material goes to the right place. Engines roar, alarms beep, metal grinds on rock. Dust is managed by constant road spraying. Workers in high-visibility gear move with purpose among giant machines. Benches stabilize pit walls and serve as roadways as the pit deepens. A dynamic environment, changing daily, chasing veins of gold deeper into the earth. From here, the rock begins its transformation into fine powder. But not all deposits can be mined from the surface. Some lie deep below. When deposits are deep or narrow, miners go underground. It's a different world. Darkness, confined spaces, intricate engineering. Access is via vertical shafts or by driving sloped declines and adits. Networks of drifts and crosscuts reach the ore. The air is cool and damp. Sounds are muffled, cut by the whine of drills and ventilation fans.
Down here, you learn to trust your training and your team. You're always checking the rock above you. The ground talks to you, and you have to listen.
Steel mesh, long rock bolts, and sprayed concrete support roofs and walls. Ore is extracted by the drill and blast cycle, then the broken rock, muck, is cleared. Loaders feed trucks or conveyors to the shaft for hoisting to surface. The cycle repeats, advancing deeper into the ore body. Safety is paramount. Training, protocols, refuge stations, and constant monitoring of stability, air, and seismicity. Underground mining requires courage and skill, where human endeavor meets raw geology. Now, ore from both pit and underground converges for processing. The next chapter, crushing and grinding. Once the ore reaches the surface, its journey to the processing plant begins. The first crucial stage is comminution. Primary crushers, often gyratory, reduce boulders to manageable sizes.
At first crush is all about brute force, reducing run-of-mine rock for the next machines.
Further crushing leads to grinding in enormous rotating mills. Sag and ball mills with steel media grind ore into a fine slurry, wet sand to silt. Particle size is critical. Too coarse locks gold and rock, too fine complicates downstream steps. After grinding, the chemical phase begins. Leaching separates gold from rock. A dilute sodium cyanide solution dissolves gold and silver over 24 to 48 hours in a leach circuit.
It's all about chemistry and time. We control pH and cyanide concentration to maximize recovery.
Because cyanide is toxic, strict safety and environmental protocols govern its closed-loop use. Carbon in pulp. Activated carbon adsorbs the gold cyanide complex, then is screened out. Tailings are detoxified to neutralize cyanide before storage in a licensed facility. Gold is stripped from carbon in hot caustic solution. Barren carbon is reactivated and reused. A small volume now holds a high concentration of dissolved gold, ready for final recovery. Next, electrowinning, smelting, and the dramatic pour. In electrowinning cells, anodes and steel wool cathodes attract gold ions under electric current. Gold deposits as a sludgy solid, then is washed, filtered, and dried. Still a mixed concentrate.
The recipe has to be just right. Fluxes help form slag and separate impurities.
At over 100 degrees 6, gold melts and, being dense, sinks beneath a floating slag layer. This is the most dramatic moment, the pour liquid fire cast into ingot molds. Mine site bars are doré, French for gilded, an alloy rich in gold and silver. Doré is transported to accredited refineries, remelted, and assayed to determine composition. The Miller process yields 99.5% purity. The Wohlwill electrolytic process achieves 99.99% and beyond.
Our job is about precision. Every bar must meet exact weight and purity. There is no room for error.
Bars are cast in market-ready sizes, from 400 troy ounces to 1 kilogram and small investor bars. While technology is vital, people make the process possible. Skill, dedication, and resilience.
It's like conducting an orchestra. Temperatures, pressures, flows, and chemistry all at once.
Modern gold production emphasizes safety and environmental stewardship, from training to water and chemical management to reclamation. Beyond wealth, gold's density, conductivity, and corrosion resistance power, life-saving and spacefaring electronics. From a speck and stone to a stamped bar, gold's journey is human ingenuity made visible, and a responsibility to do it with care and foresight.